Good morning, my dear students. Today we are going to start with the second part of the same lesson, that is chemical reactions and equations. So today we are going to continue further things. As I explained you yesterday, that to characterize any given chemical reaction means if we want to know that whether a reaction has taken place or not, we need to find out some basic hints. We need to take some basic hints which can show that a chemical reaction has taken place or not. So I have already explained you two good examples. Now today we are going to start with the third example, that is reaction of hydrochloric acid with zinc granules. So now let us get started, that what are these things of. So first of all, you can see here that we are going to react HCl with the zinc granules. So this first thing is very clear, that the two things that we are taking is HCl and zinc granules. Now see, let us start reading. When concentrated hydrochloric acid solution is added, means we are taking this hydrochloric solution and now we are adding to a test tube. Means what we are doing is we are adding this thing to a test tube which is already containing zinc granules. Means we are taking the hydrochloric acid solution. Means here we have taken one test tube. Here we have already present here zinc granules. Now we have added inside it our HCl solution, and this is also concentrated. What is the meaning of concentrated and what is the meaning of diluted, that we are going to understand when we are starting with our second unit. But you should know this time that one thing which is very strong, or we can say the strength, if the strength of this acid is more, means it is more concentrated. Now we are adding this concentrated hydrochloric acid into this test tube which contains zinc granules. Then after some time we can observe the bubbles which are coming out of that test tube. So we will see that bubbles are evolved. It will be looking like this, that here is a test tube, here will be the solution, and here are the bubbles which are formed inside this solution. These will be coming up in the form of gas. Now we should know that what are these bubbles of, why these were not coming earlier, and now why are these coming right now only. So when we tested that what are these bubbles made up of, we came to know that these bubbles are made up of hydrogen gas. This is the first thing, that the bubbles are of hydrogen gas, and the representation of hydrogen gas, as you already know, is H2. So the bubbles are made up of hydrogen gas. Secondly, it is a displacement reaction. Now yesterday I explained you the term double displacement. Today I am only telling you displacement. So there must be a specific difference. Thirdly, this reaction, adding of hydrochloric acid to zinc granules, is an exothermic reaction. Now what is the meaning of exo and thermic? Exo and thermic. Thermic means heat and exo means released. So heat is released out from this reaction. When this reaction takes place, we get a large amount of heat. So what we can write is here, that here along with that this heat is also released in this given reaction. Now see what is the reaction. So the reaction is, here we have taken zinc, and this S shows that it is in the solid form. Here we have added concentrated hydrochloric acid. Now why we have added this 2, that we are going to study when we will try to balance these reactions in the later part of this video. This is liquid, in liquid form. Now when we mix these both, we got one product, that solution. This solution which we can see is of ZnCl2. Here we'll get ZnCl2, and along with that we'll get another thing, that is H2 gas. Now H2 gas, it is gas, and here we have shown this arrow. This arrow means that it is coming up. Okay, this is coming out of the solution. So this is the basic thing, that is a reaction of HCl with zinc granules. Now having read this, let us see the mechanism of this reaction, means how this reaction takes place. So I have already told you that it is just a displacement reaction. Now what is the meaning of displacement reaction, where only one thing gets displaced? So here AB was the already thing existing. Now do you know what is this AB? Now if I tell you that what is this AB all about, so it is HCl. Here A was H and this B was Cl. So this AB is HCl, and this C is what? What is this C? C is that zinc. Okay. So AB was HCl and C is the zinc. Now we got HCl, which is our ZnCl2. Now you see C was zinc and this C got with A. Means if we see here that this zinc get merged with this chlorine, means other than this we can also get this type of product also, where we get BC and A is separated out. So this we have got here. Now this is the displacement reaction. Now let us see what are the characteristics of chemical reaction. After seeing these three reactions, in detail. Now we should understand that what are the characteristics of chemical reaction. That is a type of summary. So first of all, if there is any change in state, for example, we took the liquid HCl, and finally from this H gets separated and we got hydrogen in the form of gas, means this liquid changed into gas. Here it is a change in state, so we can say that this above reaction which we discussed is a chemical reaction. If there is a change in color, then also it is a chemical reaction. For example, we had a transparent solution of lead nitrate and potassium iodide. We have done this PbNO3 whole twice plus Ki. This is PbI2, okay? So here this was a colorless solution, but finally we got PbI2 which is of white color. So from here we can say that somewhere or the other the things have changed because the color had changed. If there is a gas evolved, like here we have hydrogen, then also it is a chemical reaction. And if there is a change in temperature, for example in the above reaction the heat was released, so if the heat is released or the heat is absorbed, then again it is a chemical reaction. Now what are the fundamentals of chemical reaction, which means that while writing the chemical reaction what things we should keep in mind. So now let us read that. Now for the fundamentals of chemical reaction, we should always note that we should always put arrows in the chemical reaction, like the one which has been put here. You can see in the down part also there is one arrow put here. This is the arrow. Secondly, we should always add the states. Now how we are going to add the states, we are going to see here only in this reaction down. Then we should always put the catalyst on the arrow, means this arrow which we have, we should write here the catalyst. We should balance the reaction, and if something is evolved we should put upper arrow, means if hydrogen was evolved we put this type of arrow. And if suppose any product is formed AB which is precipitating, means it is coming down, so we should put this type of arrow. These things are also to be kept in mind. Now there is one very simple reaction which we studied first, that is a burning of magnesium ribbon. So now let us try to fill these things with all these fundamentals. Now you see over here what we have is this Mg. Wait, this is our Mg and we have O2. Now first of all we learned that yesterday we need to heat this, and for heating we showed a symbol of a burner. So that was a catalyst. Now what is a catalyst? Catalyst is the one which enhances the rate of reaction. What it is doing, it is enhance the rate of reaction, means if something is occurring, it will occur now more fast because of this catalyst. So catalyst will enhance the rate of reaction. So here also this particularly shows that this is enhance the rate of reaction. Now there is one balancing also. What do we write is, here we put 2, and again here also we have to put 2. Now how this 2 comes, we'll discuss it just after this part only. Now this Mg was solid, we put here solid. O2 was gas, we put here gas. And MgO again solid form, so we put here solid. In this way, and we can also write the things like down. Here we can write that this is what, this is nothing but magnesium oxide. Similarly, if we come to here, this was what, this was magnesium, and this was what, this was oxygen. If we write this, we get good marks in the exams also. We can balance the chemical equations. Here we are going to learn basically the balancing, means how can we follow the process of balancing the chemical equations. Let us see that one by one in detail. Okay, so balancing chemical equation refers to balancing the stoichiometric coefficients of the reactants. Now what is the stoichiometric coefficients? Stoichiometric coefficients were those numbers which are coming before the reactant, and product sides, which is because the chemical equation must obey the law of conservation of mass. Now what is the meaning of law of conservation of mass? Law of conservation of mass says that matter so it says that matter can neither be created nor be destroyed. This is the law of conservation of mass, which says that matter can neither be created and it can nor be destroyed. So what is the meaning of this here? We means that if we are taking magnesium 1 only, then in the products also we should have only one magnesium. Now suppose by chance, we have already learnt in our previous classes that there is a specific formula. So suppose you take on one side magnesium only, but on the product you form let us take another example. Let us take the example of sodium. Here we took sodium and in the product we formed sodium carbonate, but we know the formula of sodium carbonate, it is Na2CO3. Now you can see here one thing very carefully, we have this 2. Now this means that this here we have the 2 atoms of sodium, but here we took the 1 atom of sodium only, which means that we have to balance this because sodium atoms should be equal. Why should they be equal? Because they are following the law of conservation of mass. So according to this we should put here also 2. In this way we can balance the equation. Similarly for carbonate, if we write the full thing here, then we should balance for the carbonate also. So this thing is must to be done. So now we should see the steps of how can we balance the given equation. Now for the steps, the first thing is that we should write down the unbalanced chemical equation. Now we are taking here one chemical equation. It is like this: Fe plus O2 gives Fe2O3. You know this Fe is what? This Fe is iron, this O2 is oxygen, and this Fe2O3 is iron oxide or ferric oxide. Now write down the number of atoms. You can write down the number of atoms of each element present on the reactant side, means here also and here also. Now how will you write? You can write in this way that you will make a table, and in table one side you will write reactants and one side you will write products. Now you see here how many iron atoms are there, how many oxygen atoms are there. Here also how many iron atoms are there and how many oxygen atoms are there. In the reactant side you see only one iron atom is there, I will put here 1. But in the oxygen 2 atoms are there, I will put here 2. Similarly in the product side we get 2 iron atoms, so I will put here 2, and 3 oxygen atoms, so I will put here 3. So this is another step done. It is well sorted. Now let us see what will happen further. Now further on we have to add the coefficients to balance the mass in a chemical equation. The coefficient that are to be added must be a whole number. Now it cannot be a decimal, it cannot be a fraction. Major times it should be a whole number, means it should be some specific number like this we have already here. So it must be something very whole number, and one coefficient added applies to all the atoms present in one particular molecule. For example, if I had here Fe2O3, okay, so Fe2O3, we know that iron has 2 atoms here, oxygen has 3 atoms, but if I write here 4, it means that now iron is 4 into 2 and oxygen is also 4 into 3, which means oxygen is 12 and iron is 8. So this is the basic funda, that these are the two things to be learnt in mind. So here also putting the same thing, for example we take one example of water molecule. Water molecule is what? Water molecule is H2O. Here we know that we have 2 hydrogen atoms, then 1 oxygen atom, but now we are putting here 2, which means that hydrogen are now how many? 2 into 2. Oxygen are how many? 2 into nothing here, means 1. So 2 into 1. So hydrogen atoms are 4 in this compound now, and oxygen are 2 only. This is the thing. So now let us see further what things are there. So you have to first balance the iron and then oxygen by using a trial and error method. Now what does the trial and error method says? It says that we have to first of all add number by number things on side by side. Like we can add 2 iron on both the sides, but it won't work, as on the reactant side it will be 2 and on product it will be 4. Now see how. Here we had Fe and here we had O2. Here it will give Fe2O3. Now suppose you add here also 2 Fe, and here also you add 2 Fe. Now what will happen is that we'll have here to balance this. If we see something, okay, wait, the reaction is only, this is not the reaction is this. This is our reaction. Now they are saying if we add here to balance this, if we had here 2 iron atoms, if we make here 2, we should make here also 2. So this is the first rule to be kept in mind, that whatever things we are doing, we should be aware of the things happening side by side. So if we add 2 iron atoms, these will become 2, but here it will become 4 iron atoms. Now how to do this? So instead of this, what can we do is, we have to see all over the atoms. Now see, here only one iron atom is present, okay, and here we have 2 iron atoms. Sorry, this is not there. Here we have 2 iron atoms. Now here we have 1 and here we have 2. What can be done to make this 2? We can put here 2. Now let us put here 2. So the first step will be that we have made this equation. Now calculate the things. You see what are the things happening here. Now here we have 2 iron atoms and here also we have 2 iron atoms. Okay, balanced. Now see the oxygen. Here we have 2 oxygen atoms, but here we have 3. Multiply these both the things with a number such that the things become equal on either side. For example, if I multiply here with 3, I get here 6, and if I multiply here also with 3, I get here 2. Means finally what we need to do is, we need to make the oxygen atoms equal. So multiply them with a suitable number. So what can we do is, we will multiply here this thing with 3 and this thing here with 2. So now see here, 2 oxygen atoms are already there and 3 that we added, so there are now 6 oxygen atoms. Here 3 were already there and we multiplied them with 2, because whatever things we put here, we mean to multiply those things, okay. So here the same thing is happening. We get here also now 6 oxygen atoms. Let us add this. Now a second reaction we formed is this. Okay, what do we write here? We write here 3 because we multiplied with 3, so here we write 3. And here we need to multiply by 2, we write this 2 over here. So the next section will put this. Now is it balanced? Again check, oxygen are balanced. Now you see my dear, iron here are Fe2 multiplied by 2 means 4 Fe, and here are only 2 Fe. What can be done now? You can multiply here 2 to make them equal. So finally what you are going to do, the third and the final equation will be, you will put here now 4 means again 2 multiplied, so 4 Fe, okay. And here you already have this oxygen 3, nothing is changed here, and here you get twice of Fe2O3. This is now final balance reaction. Check everything. Iron you check, here these are 4 iron, here 2 into 2 we have got 4 irons. Similarly you check oxygen, here we have 3 multiplied by 2, 6 oxygen. Here also we have 3 multiplied by this 2, so we have got 6 oxygen atoms. So this final equation is now balanced, and this is how we can balance the equation. Let us take one more example. Now let us see the reaction of hydrogen and water. We have hydrogen gas H2 and this is oxygen. This forms water. Now see here how many hydrogen are there? 2. Here we have 2. Now here you see oxygen, but actually you know oxygen is a gas, we put 2, so it is a O2. So here how many oxygen atoms? 2, but here it is 1. Now what can be done? So we can do one thing, that here we can multiply with 2 to make them equal. So our first and final equation, first equation will be H2 plus O2. Here we can write twice of H2O. Now again check the atoms. Here we have 2 hydrogen atoms, here 2 oxygen atoms, here also we have the 2 oxygen atoms, but here we have 2 hydrogen atoms in the reactant side, this one. But now check there, we have 2 multiplied by 2, we have total 4 hydrogen atoms. Now what to be done? Here you can multiply by 2. So our second equation will be twice of H2 plus O2 gives twice of H2O. Check, 4 hydrogen atoms, 4 hydrogen atoms, 2 oxygen atoms, and this plus this we get 2 oxygen atoms. So this is our final equation. This equation is now balanced. So that's all for the day. Thank you.